Some communities along the Texas Hill Country are still recovering from the flooding that came through last summer. Right now, the exact same flood corridor from northeast Texas all the way through the Ohio Valley is being flagged by the Weather Prediction Center as the zone to watch most closely this season. That is not a coincidence. That is a repeating pattern. And today I want to walk you through exactly why this summer is being set up differently from anything we have seen in recent years. I want to take you through what the next 7 days look like across the Central Plains and Upper Midwest. I want to show you the heat event building across the eastern half of the country, heading into the 4th of July week. And then I want to get into the one force sitting underneath all of it, that 3 major independent modelling centres now agree could potentially rewrite the record books before this year is finished. This story starts with the next 48 hours, because what is happening right now on the radar is directly connected to the larger pattern. So let us start there. Today is Friday, June 27th. Between now and Saturday morning, the central and southern plains are in the crosshairs of a flash flooding threat. The Weather Prediction Center issued a moderate risk of excessive rainfall for south-central Kansas as of the latest discussions, centered on a slow-moving frontal boundary draped from Wisconsin south and west into the Central Plains. Surface cyclogenesis is developing over eastern Colorado and pushing east with a shortwave trough rotating through the mid-levels of the atmosphere. That surface boundary is not moving quickly. That is the problem. When a stationary front like this interacts with Gulf moisture streaming north and repeated shortwave energy coming off the Rockies, you do not get one round of storms and then cleanup. You get training cells. One line of convection after another dropping heavy rain in the same places over and over for hours on end. Flash flooding becomes the primary headline threat in that scenario, not severe wind or hail. The volume of water arriving faster than the ground can absorb it is what creates the danger. Here is who needs to watch this the most through tonight and into tomorrow morning. Central and southern Kansas around Wichita and Hutchinson, northern Oklahoma from Enid toward Ponca City, the Ozarks of Missouri and Arkansas, particularly the creek and river drainages east of Springfield and west of Joplin. These areas have already absorbed significant rainfall this month. In many locations, the soil is at or near saturation. Additional rainfall totals of 2 to 4 inches are possible in the next 24 hours, with locally higher amounts possible where cells train repeatedly along the same corridor. If you live near any creek or river bottom from Wichita south through Tulsa and east into the Ozark foothills, you need a plan before this evening. Know your evacuation route. Do not drive through water on any road. Flash flooding kills more people than tornadoes in most years in the United States. It does not announce itself with a siren. It arrives faster than most people expect, and it shows up in places that have never flooded before. Now, as we move into Saturday the 28th, the pattern shifts north in a meaningful way. A strong upper trough advancing into the northwest United States will drive a surface low to develop across eastern Wyoming into the western Dakotas. The Storm Prediction Center was already watching this setup as far back as Wednesday's day 4 through 8 convective outlook discussion. That discussion specifically flagged a lee cyclone developing across eastern Wyoming into western South Dakota, with southerly flows strengthening and advecting low to mid-60s dew points northward. By Saturday afternoon, that scenario looks to be verifying. The GFS and the Euro both show this surface low deepening through the afternoon hours across the Wyoming and South Dakota border region. When you combine that deepening low with deep layer wind shear of 30 to 40 knots, you have a textbook setup for long-lived rotating supercells. The SPC has outlined a 15% probability area for severe weather Saturday afternoon and evening across the western Dakotas. Those numbers carry the caveat that the area may need to be refined in future outlooks as the event gets closer. That is forecaster language for, this could go higher. The uncertainty is not whether storms develop. It is exactly where the initiation zone sets up relative to the strongest shear and instability. What does Saturday afternoon look like on the ground? Discrete supercells initiating east of the Bighorn Mountains near Gillette and Buffalo, Wyoming, by around 2 or 3 in the afternoon. Those early storms will have access to steepening lapse rates and strong instability. Very large hail, golf ball to baseball size in the most intense cells, is explicitly on the table for the initiation zone from eastern Wyoming into the western South Dakota Badlands country. By evening, activity will sweep northeast into western South Dakota near Rapid City, then spread across the central and eastern Dakotas through the overnight hours. The cold pool generated by the leading edge of the storm complex can undercut the warm air feeding the system, causing the line to bow out. In a bow echo scenario, peak wind gusts of 70 to 85 miles per hour are possible across eastern South Dakota and into southern Minnesota. If you live from Rapid City east through Pierre and Aberdeen and north toward Watertown, Saturday evening into Saturday night requires you to take this seriously. Have weather alerts active, know where your shelter is before dark. On Sunday the 29th, the low tracks northward into south-central Canada. A brief lull settles across the northern plains and upper Midwest through Sunday afternoon. Do not interpret that lull as the end of the pattern. That pause is the atmosphere resetting for the next round. Into Monday, June 30th and Tuesday, July 1st, the next major story begins. The WPC extended forecast discussion from Thursday morning is very specific about what is coming across the eastern half of the country. A building downstream upper ridge across the east-central United States will result in increasing heat and humidity, going into much of next week with widespread 90s across the eastern half of the country. Those are the WPC's own words. This is not one model run. This is operational forecast guidance, and it is describing a multi-day heat siege driven by a deepening ridge that models have been showing in a consistent trend for the past several days. The mechanism is straightforward. As the trough over the Pacific Northwest pushes the surface low northward into Canada, a ridge builds immediately downstream across the central and eastern United States. That ridge suppresses cloud cover. Clear skies allow maximum daytime solar heating. Surface temperatures rise. The ridge reinforces itself. Breaking that kind of ridge requires either a significant trough to dig deep from the west, or a tropical system to disrupt the pattern from the south. Neither of those appears imminent before the middle of next week. Heat index values in the Ohio Valley, the Tennessee Valley, and along the I-95 corridor from Washington through New York could reach 100 to 105 degrees by Tuesday through Thursday of next week. Dew points rising into the upper 60s and low 70s, combined with high temperatures in the low to mid-90s, produce those dangerous heat index values. This combination affects the body differently than high temperature alone. When humidity is high, the body cannot cool itself through evaporation of sweat as efficiently. Heat stress accumulates across multiple consecutive days faster than most people realize. If you have family members who are elderly, work outdoors, live without reliable air conditioning, or have underlying health conditions that affect heat tolerance, the 4th of July week period warrants a direct check-in with those people, not a text, an actual check-in. By Wednesday, July 1st and into the holiday weekend, the heat expands east. The models are consistently showing the ridge axis building over the east-central country, which draws southwesterly winds up from the Gulf Coast states and pulls warm, moist air into the entire eastern corridor. Boston, New York, Philadelphia, Washington, Baltimore, Charlotte, Atlanta. All of these cities are trending toward multi-day periods in the low to mid-90s with significant humidity. For cities that have been experiencing a relatively cool first half of June, thanks to the frontal activity, this will feel like a sharp and sudden transition. I am Arthur. This is Sky Space Lab. If you have been watching this channel for a while, you know that I put out new content every time the pattern makes a meaningful shift. And right now we're inside one of those moments. A pattern shift that is not just day to day, but seasonal. Before I get into the biggest part of this story, hit subscribe if you have not already. It is the best way to make sure you get the next update when it comes, and given how active this atmosphere is, it is coming soon. Now here is what is driving all of this. When was the last time your area went a full 7 days without a severe weather threat, a flash flood advisory, or a heat warning? If you are in Iowa, Nebraska, Illinois, Indiana, or any of the states across the central and eastern corridor, put your city in the comments. Tell me what June has actually looked like from where you live. I am asking because I am sitting here looking at data that describes one of the most energy-loaded atmospheric patterns for a June that I have tracked in years, and I want to hear from the people who are living inside it. Here is what the raw numbers show so far. June 2026 has produced the second fastest start for damaging straight-line wind reports since comprehensive severe weather records began in 1955. The pace we are on has been surpassed only by June of 2008, which was one of the most destructive June weather months in the modern observation era. Illinois alone reached a preliminary tornado count of 145 tornadoes through the middle of June. The previous full-year state record for Illinois was 147 tornadoes set last year, and we have not reached July. The mid-June outbreak specifically produced a confirmed large EF3 tornado near Dix in Jefferson County, Illinois, with fatalities. A PDS, particularly dangerous situation tornado warning, was confirmed in Gibson County, Indiana. An EF2 struck along the Sedgwick-Harvey County line in Kansas. 95 total tornado warnings were issued across the Midwest in a single outbreak sequence. These are not numbers from a typical June. This is an atmosphere that has been running at a significantly elevated energy level for weeks. And the Storm Prediction Center is not signaling a break. The day 4 through 8 outlook from June 24th was already flagging the northern plains and upper Midwest for additional severe weather potential for late next week. The cycling trough pattern I described for Saturday and the following week is going to persist. The GFS and the European model are in agreement on this. Every 3 to 5 days, another shortwave rides through. Every 3 to 5 days, another surface low develops, and every 3 to 5 days, another round of instability fires across the plains and Midwest corridor. The Derecho threat for early July is real. When broad westerly flow pushes across the northern plains and low-level jets amplify overnight wind shear, mesoscale convective systems can organize rapidly into bow echoes and sweep hundreds of miles in under 12 hours. AccuWeather's 2026 Derecho season forecast places the most likely corridor from South Dakota to central Kentucky, threading through Iowa, Missouri, Illinois, Indiana, and eastern Nebraska. The peak climatological window for derechos in that corridor runs from the second half of June through all of July. We're in the middle of it. Now I need to step back from the week-to-week pattern. What I have described so far does not make full sense without understanding the force reshaping the atmospheric state across the entire northern hemisphere right now. The flash flood threat today, the supercell risk Saturday, the heat event next week, the repeated severe weather setup cycling through the plains, none of it in isolation captures what is actually happening. Something is happening in the Pacific Ocean that I have been watching since the early spring, and what I am seeing in the data now is not what I expected when I first started tracking this signal. It is bigger. El Ninyo is officially here. NOAA confirmed earlier this month that El Ninyo conditions have developed in the equatorial Pacific. That confirmation came after months of a powerful Kelvin wave, a pulse of anomalously warm water driven eastward below the surface by intense westerly wind bursts, surfacing in the eastern Pacific and driving sea surface temperatures above the threshold. The Nino 3.4 region is already approaching plus 2 degrees Celsius above normal this summer, and that is before the event reaches its peak. The peak is projected for late fall and early winter, but what separates this from a typical El Niño is what the models are now projecting for where that peak ends up, and here is where I need you to pay close attention, because these numbers are genuinely historic. 3 major independent modeling centers have now converged on a projection for the peak of this event. The ECMWF Seasonal Ensemble projects peak sea surface temperature anomalies of plus 3 degrees Celsius in the Nino 3.4 region by November, with high-end ensemble members reaching plus 4 degrees. The NOAA climate forecast system is in broad agreement. Australia's Bureau of Meteorology is showing the same signal. For context, the strongest El Niño ever measured in the modern instrumental record was the 2015 to 2016 event, which peaked at plus 2.6 degrees Celsius. A plus 3 event would exceed that record by 15%. A plus 4 degree event would put us in territory we have not documented with modern instrumentation. The only historical analogue that climate scientists reference at that magnitude is the 1877 to 1878 El Niño, which is associated with some of the most severe agricultural and weather disruptions of the 19th century across multiple continents. I want to be exact about what we know and what we do not. These are long-range seasonal model forecasts. Uncertainty exists, especially at the upper end of the ensemble spread. But here is what makes this forecast cycle genuinely different from routine long-range speculation. With each successive seasonal model update cycle since March, the projected strength of this event has increased. March showed a strong El Niño, April showed a stronger one, May showed a stronger one still. The June update was stronger again. When a forecast trend moves consistently in one direction across multiple independent model update cycles with different initial conditions, that is not the models fluctuating around a mean. That is the models responding to a real physical signal in the ocean that is becoming more unmistakable with each new observation. NOAA is now assigning a 62% probability of El Niño conditions persisting through at least the end of 2026. The agency also assigns a 63% probability of a very strong event, defined as a Nino 3.4 anomaly of +2 degrees or more between November 2026 and January 2027. Let me put that in perspective. The baseline for El Niño onset is +0.5 degrees. The threshold for strong is +1.5 degrees. The threshold for very strong is +2 degrees, and NOAA is giving 63% odds we reach or exceed it. The ECMWF median forecast projects +3 degrees, 50% above the very strong threshold. What does a developing Super El Niño mean for the patterns we are already experiencing right now, this summer, before the event has even reached its peak? Start with the jet stream. In a developing strong El Niño summer, the subtropical jet stream gets enhanced across the southern tier of the United States. That enhancement pushes additional moisture and storm energy from the Pacific into the southern plains, the Gulf Coast states, and northward into the Ohio Valley. AccuWeather meteorologist Paul Pastelok specifically stated in the 2026 summer forecast that other impacts this summer can include wetter conditions across the Central Plains, Mississippi Valley, and Ohio Valley. NOAA CPC's summer outlook points toward above-normal precipitation probabilities across a broad corridor from Texas through the Great Lakes. The IRI Columbia Climate Center is signaling the same pattern. This is not one organization's view. This is a consensus across multiple major forecasting centers. Now look at what is already verified this year. The March heat dome set more than 1,500 temperature records across 11 states in the western United States. Drought has been worsening across the Northwest, Northern California, and parts of the Gulf Coast. AccuWeather is explicitly calling for wildfire conditions to be destructive across the Northwest and Great Basin, with impressive heat waves and drought expanding through the entire summer across Montana, Idaho, Nevada, Oregon, Utah, Wyoming, and Washington. Meanwhile, in the central and eastern parts of the country, the opposite is happening. Near-record wind damage in June, a historically high tornado count for Illinois, repeated flash flooding events across the Plains corridor, multiple heat events across the eastern seaboard. This geographic split, hot and dry in the west, stormy and wet in the center, is precisely the atmospheric fingerprint that a strengthening Super El Ninyo produces in the summer before its true peak. The pattern does not wait for November. The reorganization of the atmosphere has already started, and it is going to intensify. Here is something I want you to consider that most forecasts do not give enough space to. This is not just a United States story. The same Super El Niño signal that is reshaping our severe weather pattern and building the heat dome over our eastern seaboard has already driven Europe into one of its most extreme early summer heatwave sequences ever recorded. France recorded temperatures approaching 45 degrees Celsius during the June outbreak, which is over 113 degrees Fahrenheit. Germany, Belgium, the Netherlands, and the United Kingdom all recorded temperatures 15 to 20 degrees Celsius above their late June normals. The World Meteorological Organization has been tracking the global signature of this same Pacific warming signal across multiple continents simultaneously. This matters for understanding the US pattern because the global jet stream is one connected system. When the Pacific El Niño signal reorganizes the tropical circulation, it sends wave energy rippling around the entire northern hemisphere. The atmospheric ridge that produced the European heat outbreak is part of the same large-scale pattern that is building the ridge across the east-central United States next week. This is not two separate stories. It is one story told in two places, and the driver of both is the same warming ocean signal in the equatorial Pacific. The specific Kelvin wave that triggered the rapid intensification of this El Niño event this spring was described by climate scientists as unusually powerful. A Kelvin wave is essentially a pulse of warm water below the surface of the ocean, driven eastward by changes in the trade wind pattern. When it arrives at the coast of South America and wells up to the surface, it releases that stored heat into the atmosphere. The 2026 Kelvin wave was one of the stronger events observed in the modern satellite era, and the amount of heat it released into the tropical atmosphere in a short period is what accounts for how quickly the El Niño signal has shown up in the global atmospheric circulation, faster than most El Niño events at this stage of their development. When IRI Columbia, which is one of the top El Niño forecasting centers in the world, updates their outlook next month, I expect to see the probability of a very strong event increase further. The acceleration of this event is consistent with what climate scientists have been tracking in the subsurface temperature profiles of the Pacific for the past 6 months. The ocean below the surface was preloaded. Now that heat is arriving at the surface, and the atmosphere is responding, I will be watching every update from NOAA CPC, IRI Columbia, the ECMWF seasonal forecast, and the Australian BOM. Every month through the fall, as this event develops toward its November peak, I will be bringing you the latest data. Because what happens between now and November in that Pacific Ocean will determine what kind of fall, what kind of winter, and what kind of spring follows for the entire Northern Hemisphere. The flooding zone from northeast Texas through the Ohio Valley is not just this week's concern. It is the structural feature of the entire rest of this season. When the subtropical jet enhances and Gulf moisture repeatedly gets pulled northward by surface lows along the frontal zone, you set up conditions for prolonged multi-day rainfall events, the kind that fill rivers that are already running full from the previous round, the kind that test levee systems and drainage infrastructure that was not built for this frequency of events. AccuWeather specifically cited the Texas Hill Country flood corridor, the same region hit last summer, as one of the zones to watch most carefully this season. That is not by accident. This is one of the strongest overall summer atmospheric setups I have seen in years of tracking these patterns. The combination of an active short-range severe weather and flooding pattern, a building heat event across the eastern half of the country, and a developing potential Super El Ninyo all arriving at the same time is what makes 2026 different. Not unusual or slightly above normal, different. What most channels are not spending enough time on is what a Super El Ninyo means for the parts of the country that are not currently in the flood zone or the heat corridor, because this event has arms that reach everywhere. Take the wildfire picture for the western United States. Heat and drought have already been worsening across the northwest, northern California, and parts of the high plains. The spring heat dome that hit in March set more than 1,500 temperature records across 11 states and was declared virtually impossible without human-induced climate change by the World Weather Attribution Group. That event arrived before the El Niño signal had fully developed. What happens to wildfire conditions across Montana, Idaho, Oregon, Washington, Utah, Nevada, and the California northern interior as a genuine Super El Niño reinforces the heat and drought signal through summer and into early fall? AccuWeather is explicitly calling for wildfire conditions to be destructive across the Northwest and Great Basin through the entire summer season. This is not speculative. It is the forecast being issued right now by major meteorological organizations. The southwest monsoon is another piece of this. In a developing El Niño, the subtropical jet can enhance moisture transport from the eastern Pacific into the southwest during the summer monsoon season, which typically runs from mid-June through September across New Mexico, Arizona, Colorado, and Utah. We may see above-average monsoon rainfall in some of those areas, but that same moisture, interacting with extreme heat and dry terrain, also increases the flash flooding risk and the lightning-triggered wildfire risk in the Four Corners region and the southern Rockies. El Niño impacts are never simple. They push moisture and energy actions than the lower-level winds that are feeding the storm. This is the basic mechanism by which El Niño tends to suppress Atlantic hurricane activity. In the most powerful El Niño events, the Atlantic hurricane season can be dramatically below normal. In 1997, which was the onset summer of the 1997-98 Super El Ninyo, the Atlantic season was extremely quiet with only 3 hurricanes. We will be watching carefully to see if a similar signal develops this year. But there is a competing factor. The Atlantic sea surface temperatures are running above normal in key regions of the main development area and the Gulf waters. Warm water is the fuel supply for hurricane development. If El Niño shear is strong enough, it counteracts the warm water fuel supply. If the shear is not quite as strong as modelled, the warm Atlantic waters become a vulnerability again. Colorado State University, the NHC, and NOAA are all weighing those competing signals right now. I will break down the specific numbers and what they mean for Gulf Coast and Atlantic Coast risk in a dedicated video very soon. But the short summary is, the El Niño signal argues for suppression. The warm Atlantic waters argue for the potential for activity if any system manages to get organised. The battle between those two forces is what defines the 2026 hurricane season risk picture. Back to what is in front of us this week. The heat event building for next week carries a wrinkle that I want to be precise about. The WPC extended forecast describes heat and humidity increasing across the central and eastern United States for much of next week. The specific language mentions a building downstream upper ridge across the east-central country, bringing widespread 90s across the eastern half of the country. But embedded in that ridge, along its northern and western periphery, is where additional severe weather setups are most likely to develop. The boundary between the building ridge and the trough over the Pacific Northwest is a focus zone for storm development. That means the Dakotas, Minnesota, Iowa, and Wisconsin could be dealing with severe storms at the same time that the Ohio Valley and eastern seaboard are dealing with oppressive heat. Two completely different weather stories happening simultaneously across the same country. That is a signature of a pattern dominated by a strengthening El Ninyo signal. High contrast, extreme on both ends. The Derecho risk I mentioned for early July is directly connected to this pattern. When you have a building ridge to the south and east, with a trough actively digging to the northwest, the pressure gradient between those two systems can be significant. That gradient drives strong low-level jet streams overnight, pulling Gulf moisture northward and creating intense wind shear across the plains and Midwest. That wind shear, combined with high instability and a well-organized triggering mechanism from a shortwave trough, is exactly the environment that produces Derecho-type events. AccuWeather's Derecho corridor forecast for 2026, from South Dakota to central Kentucky, is not an arbitrary line. It is drawn based on where this atmospheric configuration is most likely to produce fast-moving, damaging squall lines. People in that corridor need to be thinking about their outdoor plans, their large trees, their backup power situation, and whether they have a weather alert method that wakes them up if a severe warning is issued in the overnight hours. Tomorrow, I am going to be watching the Saturday afternoon Dakotas setup very closely. The Lee cyclone development across eastern Wyoming, the supercell initiation timing relative to maximum heating, the extent of the bow echo wind threat into eastern South Dakota and Minnesota. All of it depends on exactly how the upper trough digs through the region and where the surface low ends up by late afternoon. If the Friday night model runs from the GFS and Euro confirm or strengthen the 15% scenario the SPC has outlined, I will be back Saturday morning with a focused breakdown of timing and impacts before the worst of the weather develops. Set your alerts. Turn on notifications for this channel. I do not push out content just to push it out. I do it when the data says something that demands your attention. Right now, the data is saying a lot. Share this video with anyone you know in Kansas, Oklahoma, Nebraska, the Dakotas, Iowa, Illinois, Indiana, or the Ohio Valley corridor. The people in those areas need to understand what this pattern is building toward this summer, not just what is happening in the next 24 hours. Like the video if the data-first approach is useful to you. Subscribe if you want to be here every time the atmosphere makes a move that affects your safety or your plans. Have you already felt the difference this June compared to past years? More rounds of severe weather with less recovery time, more flooding, more oppressive heat stretching out longer than it used to? Drop your city and state in the comments. Tell me what the ground level experience has been where you live. I read everything. The number I keep coming back to is +3 degrees Celsius. That is the ECMWF median projection for the peak of this El Ninyo by November. The strongest event in the modern record peaked at +2.6. Keep that number in your mind as we go deeper into this summer. We are going to be talking about it a great deal before this year is over,